Hi guys, welcome back to my channel. Myself Bharataji. Today I'm here with a small topic, mud sort with time efficiency. In this video we are going to know about mud sort. Let us move into the video. For the beginning, introduction to mud sort. Mud sort is a popular sorting algorithm known for its time and efficiency. Mud sort is a type of sorting algorithm. It follows the divide and conquer approach to sort the elements in the list. It uses a divide and conquer approaches to sort the elements in the list. Merge sort has a time complexity of theta n log n, making its efficiency for large data sets. Merge sort has a time complexity of theta n log n, and it is used for the large data sets which have the more number of elements in the list. Understanding divide and conquer. The divide and conquer strategy involves breaking down a problem into smaller subproblems. The divide and conquer technique is used to divide the larger problems into smaller subproblems. In the merge sort, the list is divided into two halves recursively until each sublist contains only one element. This divide and conquer rule helps us to have that only one element in the subproblems, and it is done recursively until the subproblems contains only one element. The merge step then combines and sorts the smaller list back together. The divided lists are sorted and bring back together at the end of the sorting. Next, merge sort algorithm. These are the steps which are involved in the merge sort algorithm. For the beginning, divide the unsorted list into two sublists. Dividing the larger list into two sublists is the first step in merge sort algorithm. Recursively sort each sub-element. Recursively, one after one, the elements should be sorted in this merge sort. At the end, merge the sorted sublist back together. At the end of the merge, space complexity analysis. Merge sort has a space complexity of theta due to the needed for additional space to store temporary arrays during the merge processing. The merge sort has an additional space of theta and which is need to the additional space to store the temporary arrays during the merge sort. The temporary arrays are stored in the space of theta. Despite the additional space requirement, merge sort time efficiency makes it a favorable choice for many applications. Despite as the additional space requirement, merge sort time efficiency make it favorable choice for many applications. In place of merge sort, variants can reduce the space complexity to theta 1. In spite of merge sort, the complex space complexity can be reduced to theta 1, but at the cost of increased time complexity. The time complexity increases at when the space complexity decreases. Next, stability and performance. Merge sort is a stable sorting algorithm. This merge sort is a stable sorting algorithm, meaning it prevents the relative order of equal elements. This merge sort prevents the relative order of equal elements. It performs well on a large datasets and is efficient for sorting a linked list. This merge sort is very efficient for linked lists and large datasets. The datasets which have more number of elements to sort and linked list likes are used more efficiently uses the merge sort technique. The stable nature of merge sort makes it suitable for applications where maintaining the original orders is important. The stable nature of the merge sort is very important for maintaining the original order and the main elements in the list. Next, aptitude merge sort. The adaptive merge sort is an optimization that takes advantages of already sorted or partially sorted list. This adaptive merge sort helps us to take the advantages of already sorted elements or partially sorted elements. It can improve the time complexity in scenarios where the input data is nearly sorted. It can reduce the time complexity when the input data is already given to the system. The time complexity of the merge sort can be reduced. Adaptive merge sort adjusts its merge steps based on the existing order of elements in the list. When there is more number of lists, the more number of steps takes place in the adaptive merge sort. When the number of list elements in the list are reduced, the merge sort takes less number of steps to sort the elements. Next, partial applications. Merge sort is commonly used in external sorting algorithms for sorting large files that do not fit into memory. The merge sort is used for the large set files which will not fit into the memory, and it is sorting technique which is used the large sets which have more number of elements. It is also used in programming languages and libraries for sorting arrays and collections. This merge sort technique is also used in the programming languages and libraries for sorting arrays and collections. Merge sort efficiency and stability makes it a versatile choice for various sorting stacks. Stacks also used through the merge sort. Next, at the end, conclusion. Mozart is a highly efficient sorting algorithm with a time complexity of theta n log n. This Mozart contains a time complexity of theta n log n. Its divide and conquer approach or stability makes it a popular choice for sorting large data set. The divide and technique which is used by the Mozart makes it very stable for popular choices for sorting large data sets. The large data sets like elements having more number of lists which will use the merge sort technique for the better sorting techniques. Understanding the time efficiency of merge sort can help in selecting the appropriate sorting algorithms for different scenarios. Different scenarios contain different examples and different lists contain different elements. For each and every element, the merge sort technique can be used. Understanding time efficiency can reduce the number of steps used in the merge sort. Thank you. Thank you for watching my video. Please like, share and subscribe.